Hi everybody, and welcome back to How To from tdp.ie. I'm Robbie Thornton, founder of TDP, and today I'm going to talk to you about setting up data logging in Link G4X. So we're here in Link G4X and we want to set up some data logging. Now this is data logging in the ECU and not on your PC, which is different because there is a choice here. You'll see when we go into set up data logging. There are two tabs, and you're going to set up data logging. There's going to be a tab for PC logging and ECU logging. Today we're only interested in ECU logging. At a later stage, when we do some dyno sessions, we'll show you the PC logging. But we want to turn on ECU logging. Now, why would you do this? Well, the answer is data is good. The more data you have about what's going on, the more you can figure out what happened in the past, why it happened, and you can make changes to improve your situation always with data. Data is good. The more data, the better. We love data. So, first thing to decide on is when you should log. Well, realistically speaking, competition car, it's probably, you could log it all the time for certain disciplines and you'll have enough logging memory. A road car, you probably don't have enough, but certainly you want to log all the time the engine is above a load where you need the data. So we normally would say 2000 RPM, above 2000 RPM. Don't worry about throttle and map. I don't normally do that. We just do simple above 2000 RPM. And then when basically the engine has dropped below 2000, we log for another 10 seconds or 20 seconds, 30 seconds. And what that does is allows us to see everything starting to cool down again at the end of a run or whatever. So, excuse me. What should you log parameter wise? Well, the most important things you need to log are the main sensors on the engine. So let's have a look at what sensors we've got. If you think about it, you've got your cam and your crank sensor are there to make the engine run. Then you probably have a throttle sensor, a map sensor, and you certainly have a coolant temperature sensor. You probably have an air temperature sensor. There's 4, but then if it's a well-spec'd vehicle, you'll probably have fuel pressure, oil pressure, you may have gear position. If it's drive-by-wire, you'll have 2 TPS sensors and 2 pedal sensors. So we'll just go through here. This base map is based on one of the Red Bull Drift Brothers cars, actually, which is pretty high spec, running G4X Extreme, and drive-by-wire throttle and a whole load of stuff. So there's quite a lot of stuff to log on this car. But let's just not get too confused over what's on the car. Let's talk about the basics that every car has. And the first one you need to do is engine speed. Okay? It's really important. We'll go through this and I'll explain why each time. So if I type in engine, it limits it down to everything with engine in the name. So engine speed and engine speed rate of change. Now, I would suggest that you log both of those at 50 Hertz. And to select them, select your frequency, select both of the channels by using shift or control and send them over. Now they're logged. Why I would suggest that you log rate of change is in certain situations where the engine speed is accelerating or decelerating, it's nice to know quickly how many thousand RPM per second it's doing without having to like try and work that out from the graph from your normal engine speed. And it allows you to work out situations where you can ignore things like fluctuations in the lambda and stuff because the engine's just accelerating really quickly, either decelerating or accelerating, and it would be impractical for the lambda to follow a nice curve. So those two I would say you should always log. Now, other things you should log while you're here is some statuses. See this one here, engine kill status. Well, that's kind of interesting because sometimes we use engine kill status, so I'm going to log that at 5 Hertz. So if the engine kill status, if your car suddenly stops, for example, and you don't know why, and you go into your log and you see that just as it stopped, the engine kill status turns on, well, you know that your engine kill switch is either malfunctioning or it did its job and you turned it off. But, you know, one way or the other, there are some statuses that will be helpful. And another couple of statuses that we always start thinking about at the beginning is fuel and ignition cut. All right. I would log them at probably 20 Hertz would do, right? Because that will tell you if either your limiters or anything are cutting in. Now it mightn't tell you which one is cutting in exactly without logging another channel, but we'll come back to that. So now you should probably log all your analog input sensors and your digital inputs as well. But before we leave this sort of crank trigger thing, I want to discuss one other thing, which is if you have a heavy miss or a stutter or the car cuts or something, you want to know, did that come from one of your primary sensors? So a good one to always log is trigger error. Okay, trigger error count. Okay, you don't need to alarm that at log that at an alarmingly high rate, because it's a counter. 20 hertz would be fine. So it continually counts up. When it gets past to 255, I think it resets and goes back, but it will continually count up. So if that's counting at all once the engine's running, it means you're getting a bogus signal from either the crank sensor or the cam sensor. Depending on your trigger mode, it's going to be a big problem or it's not going to be a big problem. You can always, if you want to be sure, log your trig 1 signal state and trig 2 signal state, and you can log them at a reasonably low rate, because they're going to do, log them at 5 hertz. They're just going to tell you, yeah, trigger sensor's there, sending a signal. But if they're suddenly not there anymore, one of them, it might tell you that your sensor's totally failed or your wiring is totally failed. So it might speed up repair in a situation where you can get back out and track for the day instead of, you know, scratching your head. So that's that. Then I think we'll look at our sensors. Now I'm just going to have a look here and fix the screen. Okay, so input sensors that are important. Well, obviously you've got temperatures and pressures. I will start the temperature. So you've got ECT, which is your engine coolant temperature. Temperature sensors generally don't react very quickly. Okay, they are pretty slow to react. So 5 hertz would be fine for the ECT. Then the IAT sensor. Okay, because I've got them here to show me what the IAT might be a bit, you know, if you have a really good one, you might get 10 hertz out of it. Probably not, but we'll shove it up to 10. Then you've got this particular car's got gearbox temp. Yeah. Sorry, what have I called the channel? Gearbox, one word. Gearbox temperature. Analog temperature 3, gearbox temperature. Okay, 5 hertz would do that. And engine oil temperature. So we can search for analog voltage 4 or temperature 4. So we could go temp, and then we can see analog voltage or analog temperature 4 is engine oil temperature. You know, there's many ways to find the parameters. Like we could, for that voltage ones now, we could actually go VOLT. No, not going to do what I wanted it to do. Sorry, they've changed that. But anyway, while we're here, battery voltage, very good one to log. Maybe log it at 20 hertz. If you've got a alternator, failing kill switch, or just you're getting bad voltage to your ECU rather than the rest of the car, it's a good idea to have that. So back to main sensor. So we've got our map sensor, manifold pressure sensor. Okay, now there's a couple of things that would be worth logging. So map sensor, I would log at 20 hertz. Probably won't see much more resolution over that. Map delta, I would also log. It's like the engine rate of change. It's a nice channel to have. Shows you when the pressure is changing really, really quickly, rather than you have to work it out work out the rate of change. And then map limit. Well, that's always worth logging. Now, it doesn't change that quickly normally, so log it at 5 hertz. But that will tell you if you've got your GP map limit cutting in or stuff like that. So that's a good one to have. Now we've got map, and then we're just going to go down. We've got fuel pressure. Now fuel pressure sensors generally pretty fast acting sensors, but I think 20 Hertz would be more than adequate for a fuel pressure sensor. And then oil pressure, a good one to have at high, right? Obviously your oil pressure is super good for, oh, I don't know how I got rotary. Oil pressure, yeah. And while we're here, we can look and we can see we've got other ones that might be useful. So post exhaust temp, okay? So in other words, this is an EGT in this car after the turbocharger. Now I didn't really want that at that rate, so I can just go over here and use that, drag down or drop down to fix it. Post exhaust temp, what else do we want to do? So this car's got flat shift, so you've got gear position. This is a very important one if you're to set up, if you don't want to damage the gearbox, so you need to get that at a high speed gear position sensor, and you want to be logging that between 50 and 100 Hertz. 50 Hertz is probably okay. And while we're here, we'll pick up the gear lever force channel, and we'll do that at 50 Hertz as well. They'll allow us to see when the stick is pulled relative to how the barrel turns, and then because we're looking at ignition cut and fuel cut, and we can also log the gear cut parameters, we'll be able to see when and where it's gone in and out of gear, and whether it's done it with the power on or power off for the dogs in the gearbox, and make sure that everything's okay. Okay, so then if you drive by wire, you really want to log TPS, main and sub, and delta. TPS, main, sub, and delta, and I would advise logging them at 20 Hertz. Okay, so that's your throttle position based on your throttle motor under the bonnet, but you also need to log your pedal to see what you're doing with your foot. I would also log APS, main, and sub. Okay, at 20 Hertz. Now, e-throttle is one thing that you would probably want to also log your e-throttle target. And while we're here in targets, we can actually log our boost target, because we're going to get onto boost in a minute. And we can log our idle target. Idle error is a good one as well. Sometimes if you're trying to trace a really smooth idle, it's nice to be able to see that. If your car's got VVT like this has, you can actually log your inlet bank target as well. So now what we've done, and I'll pick up our AFR target while we're in here. So we're doing a lot. So we're going to pick up the AFR table target, the boost target, the e-throttle target, the idle target and target error, and our inlet bank target. So that's loads. Okay, but they're all very relevant. Now I'm still looking at e-throttle. So one of the other things we probably would be interested to know for our e-throttle, just to make sure that nothing is going untoward, is the duty cycle normally from the e-throttle on aux 10 and 9. I don't really worry about anything other than the duty, and what you want to make sure is that when it's holding the throttle at a part throttle situation, where you're not changing the rate of change of the throttle very quickly, or you're just holding it at 30%, that you're not drawing a large amount of duty. If you're drawing 80 or 90%, your PID is really set up wrong. So I think it's important to have those in the log. They'll also tell you if the throttle's suddenly not working, why. So that's most of the throttle stuff that I normally log. You can log everything. If you have a specific area that you're trying to fine tune in a vehicle, you can go back and then log all of it. So you could clear out some of this, or just log extra on the day. You could log everything to do with e-throttle and make yourself a sheet for diagnosing that, or tune in your PID or whatever, and keep downloading logs, tweaking that bit only, and away you go. But I'm just talking about general things. So now looking at what we've pulled in a few minutes ago, we've got AFR target, but we haven't got lambda. So if the car only has one lambda sensor, well, we certainly want to look at what the lambda sensor is doing. Okay, So we want to pick up the lambda sensor at 20 hertz. But then it would be interested to pick up lambda error status, lambda 1 temperature. I wouldn't say that you need to do those at a particularly high speed, so we'll pull our drop down to 10 for those ones, and maybe closed loop target error on lambda 1 and closed loop lambda status, and fuel correction if you really want to be doing. You can put all the fuel corrections in if you want to be doing a lot of that. I don't know whether this car is closed looped ever. I don't think it is, but for a car that's closed loop, yep, that's a good thing to have. So there's a lot of other lambda parameters because you can have up to 8 lambdas. We only have one. That's lambda error, but let's have a look back in our list. So where we pulled all these targets in. So we got AFR target, right? We've now got the parameters to match that. Inlet bank 1 target. So that's our VVT. So now we want to see, right? So the status of our VVT, right? Inlet 1. The duty cycle to it was probably a useful thing to have as well. And we want our inlet cam position. Because there's no point knowing what the target is. Inlet bank 1 position and error. And I might put them at 20 hertz. Okay. So we have the target. We have the target and we have the position and the error. Okay, idle target, error and idle target. Well, if the car is drive-by-wire, so we have already got all the rest of the throttle stuff, so we don't need to do a whole lot more with idle. Boost target. Okay, so for boost control, it's useful to have, because it's something that needs a lot of tuning on track for different rates of change and stuff often if you're really fussy. So boost control, it's really good to have the wastegate duty to your solenoid. Boost target we already have, but I'm going to select that now anyway just to show you something. So other things I would log would be the proportional, integral and derivative, so you know what they are and how they're working while the boost control is active. Okay. Now if you have, and boost target, sorry, and click that and it will say parameters already in list. That's because you can't add something twice, which is handy. One of the other things is active boost table status. So if you have multiple boost tables, it would be nice to know which one was in use at the time. So if we select that at 5 hertz, it's high and low boost switches in this car, but we've selected the table. That will do, save us a whole lot of hassle. And boost status will also tell you the status of the boost control. So that's everything that you would need to do with boost control, and you already have target and you already have your map. So that will allow you to do a good bit of analysis and fine tuning on boost control. So boost control, e-throttle target. Well, e-throttle target, I have most of my e-throttle stuff already that I said that I wanted, because I have the 2 throttle position sensors logged and I have my duty logged. It's probably not worth, unless you have a problem, looking for the PID for the e-throttle. Assuming that you're on track with it means you'd have your PID pretty well set up, because if you come off the dyno and your PID is not set up well on your throttle, that's a bad situation. So we would imagine it is. Other things then probably that are really useful to have now, I'm starting to run out, is probably your 5-volt output, your 5-volt analog output status, just in case there's an issue with it, your 3.3 internal and your 12-volt internal. That will just give you an idea very quickly if there's something shorted out on the engine. Like if the thing totally stops and you just don't know why, you can look at those channels and say, oh, well, my 5-volt is reading 0 volts, so it's obviously grounded, or my 5-volt is reading 12 volts because it's rubbed through a wire that's also rubbed through a 12-volt wire, and you know, that's why everything's going haywire. So basically we have now a good setup of sensors and functions that they can do. There are a few other little things that you might want to log. What I need to do is I need to close this now. So what I'm going to do is I'm going to set it as default and click OK. That'll close this, and then we're just going to change some stuff in our tree here. Unfortunately, you can't change stuff in the tree when it's active. You can scroll the tree, I think, but you can't open or close new things in the tree. So I'm just going to open up auxiliary outputs and DIs. Now I want to look at the input pins for the DIs. So we've got e-brake, clutch, high switch, anti-lag on and off. So yeah, it might be worth having the e-brake and the clutch in and the anti-lag on and off switch in the logging. So if you just go set up logging, we'll put them in. And then last but not least, after those, because I want to keep this a bit short, it's already getting quite long, I want to put in the really important things, which are to do with fuel and ignition, what's actually been delivered to the engine. So if we just type in clutch and get our clutch switch, clutch switch is on DI1 CLU. Okay, so clutch status, so clutch DI1, clutch status, DI1 input clutch status, e-brake switch, E space B, e-brake switch status, might do high boost. So maybe the other thing I could do is just do DI. So if I do DI, you get all your DIs here, which just makes it easy. So we can go high. No, we need the statuses of those. So e-brake, high boost switch, anti-lag, and we have this other one, which I hope doesn't cause any offense to anybody. It was for low boost, and our brake switch. Okay. Then we will now go to the important stuff. So injectors. Okay. First thing that probably really important is to log is basically your injection actual pulse width, probably at quite a high rate, 20 Hertz at least. Injector duty cycle and pulse width, very useful. Now trims sometimes are very important as well. So then you can see where something is happening from. So depending on what you're doing, maybe 4 and 5D tables active, we'll pretend you have. Anti-lag fuel trim possibly is in. We'll do the ignition trim since it's here. We're in trims. We'll do ignition and fuel now together. Engine coolant temperature ignition trim, engine coolant temperature wastegate trim, drive fuel trim, probably don't have that now. Ignition or air inlet temperature ignition trim, air inlet temperature wastegate trim, gear shift fuel trim. We do use that if there's closed loop gear shift. When we go through setting up these functions, we'll let you know. Gear shift ignition trim, put that in. Gear shift wastegate trim, we'll put that in. And then if you're using launch control, launch fuel and ignition trim, your limit ignition trim, your overrun ignition trim was a good one to have. Transient ignition trim, I use that a lot. And that's most of the trims. Now we would probably put them in at 20 Hertz. They don't change too fast, but some of them do, the gear one and all. And now we'll look at, so now we've got our fuel trims, and we've got our ignition, but we don't have our main ignition, which is ignition angle. Okay, so we got our ignition angle, and we'll put that in. And basically, I think that completes everything that I think is needed now to give you a fairly good overview of your engine. So what I'm going to do is basically we're going to make another video of looking at this data and what it means, how you can improve your vehicle's running by looking at the data and making small changes, not necessarily to fundamental dyno things like the main fuel map and the ignition map, but more to the trim maps and to the auxiliary functions like boost control, cam control, launch control, traction control, all of these other controls that are outside the main core running of an engine, which is ignition timing and fuel. But ignition timing and fuel will be affected by the trims, but what you might find is that your AFR just creeps a tiny bit rich here and a tiny bit rich there, or lean or whatever, with some environmental conditions, and by using the data logging you can bring it back to what you'd exactly like it to be, or what your tuner has set it to be, for conditions where the environment has changed slightly in a way that the environment could never have been replicated on the dyno. In other words, if you go out and you've got an absolutely scorching hot day in a normally aspirated car, and your air temperatures are way through the roof and your air density is low, you will probably find that it's probably a bit rich. Well, what you can do is you can obviously trim that at the high temperature only without changing the ignition map. You just use your trims, and we'll show you how to work out how much you should trim by, and that will allow the car to run better the next time it reaches those set of conditions, but it won't affect its normal running in the conditions where it was mapped or used normally in a normal day. So I think it's worthwhile looking at that. So before we finish, we must save this. So if you're happy with those set of parameters and this is your car and you think, oh, I'll use them again, I would set them as default. That means next time you come in here or go in and you've accidentally deleted them all or decided to delete them all, you can just go add default and it'll put them all in. So the next thing is you must go OK. But then the next thing is obviously you must send this map to the ECU and commit it. So you need to save your map. Save your map. So it's just an example map now. It's based on one of those. Save your map. Bring your ECU online. So your ECU becomes online. So you're now connected to your car. ECU is online. So then to send a file to the ECU, you go File, Open, pick your map, and it will then warn you that it's going to program the ECU, and you can go yes, downloading data to the ECU, and to commit that data to stay in the ECU you must do a Control S. So it's offering you to do that, forming store. Ooh. And it's disconnected from the ECU for some reason. Oh, my power maybe have gone off. No. Yeah, sorry, I had a fluctuation at my power supply here. I think caused the ECU to turn off. So says it's connecting. It's a bit slow. My computer's probably quite slow. I was shooting a video. Oh, my power supply's gone. Okay, so anyway, I'm having a small technical difficulty with my power supply. So basically, yeah, just make sure that you've loaded it to the car and hit save, so that actually the map with that logging parameters is in the ECU. Otherwise, you won't get what you expect. So quite a long-winded half an hour, but it's not one of these subjects that's easily approachable in 5 minutes. You need to understand the parameters, what some of them do, why you would put them in, before you get into it. And with that, I will say we'll see you again soon. Thank you.